Good morning. Thank you so much, everybody, for coming in today's meeting. Today's PR meeting, Dr. Sagar Paudel from Hills College will be presenting on inquiry-based experimental physics. So, uh, without any further like taking of my time, so I would like to request Dr. Paudel to present on the topic. Thank you so much.
Thank you, Gururai, and I would like to take this opportunity to thank ANPA, Division of Physics Education Research, for providing opportunity, especially for new faculties like me who are interested in this field, but we don't have any formal way getting into and knowing except the self-study. So this kind of a meeting will help us a lot. So I'm going to talk about an effort to improve physics education over 2 decades. So this is based on the paper from Beth Thacker. I'm not sure I pronounced that correctly, but yeah. So in this paper is a big paper. It is supported by 3 NSF grants. So there are a lot of things to learn in this paper. So I'll not go into detail of everything, but I'll try to present the chronological development, how they develop different aspects of this project over 20 years. So here is my outline. They developed the curriculum between 2000 and 2003. In that time, they implemented in small sections, 1 or 2 sections. Then they expanded to different population in 2004 to 2008. And then they scaled it to initially they applied this course to 24 student section. And between 2009 and 14, they expanded it to a section of 60 students. So, and then they did large scale assessment. So they assess the conceptual understanding, and in conceptual understanding, there was a little bit not significant difference from other techniques and the inquiry-based technique. So they went on to measure the assessing thinking skills. So, and lastly, in 2019-2023 period, they developed a tool to measure the pedagogical content knowledge in light of the Socratic questioning. So I'll try to lay down the chronological development of these all. So when they started, their main goal was to create a lab-based course, uh, which is based on research, and it is designed as a guided inquiry, where a student will predict, experiment, and then they create the model. So their original goal was to offer a class without any textbook. And the theoretical framework they used for this is the constructivist framework, where the framework says that the knowledge is constructed by the learner and it is not the static thing, it is a dynamic thing. As learner learns new knowledge, they will modify their thinking, their belief about those things. And learning is a social activity. So those are the basic uh, assumptions of the constructivist framework. I'm sorry. And there are some implications of constructivist framework. So teaching is not a transmission. It is the um, teaching is not just the transmission. It is a way of teaching them, like instead of giving a fees, it would be better to teach them how to catch a fish, so something like that. And then instructor need to understand the students' perception, students' preconceptions in order to amplify them, in order to guide them in the right direction. So those were the uh, outline they were looking for. And the main research question of the project was, what is the drawback and what is the benefit of inquiry-based research, inquiry-based algebra-based introductory physics sequence course in compared to the traditional teaching style. So they started with that research question, and with time, the research questions evolved into more branches. So as the need arose, they developed research question, and they branched out into 4 main research questions. This is the original one. First one is the original one. How does the inquiry-based course compare to the traditional course? And they move on to how the thinking skill of a student will change by this new inquiry-based course. And then the next question is, can we scale it up? So they started with 24 section, and they wanted to expand it to the 60 student section. So yeah, that was their another question. And the last one, how we can evaluate the learning assistants. Learning assistants are basically undergraduate students who took this course before, not necessarily in the same format, not necessarily in the inquiry-based format, but they have taken this course before and done well in past. So they have content knowledge, but not necessarily the pedagogical content knowledge. So their fourth question was, can we evaluate how LAs are doing? So they worked on that part towards the later part of the course, and it is ongoing process. So initially, from 2000 to 2003, while they were developing the course curriculum, they offered small section classes at 2 places, one at Texas Tech University, where the author is located, and another at the Grand Valley State University in Michigan. And so most of the things were same, but there are some differences between how they offered 2 classes at 2 places. At Texas Tech, they offered it as a 5-credit-hour class. They made 3 times a week, and they didn't require any text. But Grand Valley State University offered it as a 6-credit-hour class. They made 3 times 2 hours per week, 3 times per time 2 hours, so total 6 hours per week. And they assigned a textbook for that. But other than that, they have almost same approach. So the class was divided into group of 4 students, and in class, students use computer and experimental equipment to go through the material. Instructor, rather than directly tutoring, rather than directly lecturing, they circulated about the room. They checked the students' understanding at specific points, key points, using Socratic questioning, where they guided the students' learning by different questions. And they also assigned homework problem weekly and graded them. They used the student journal, to understand how students are feeling about the course. And then one interesting thing I saw in the paper they implemented is the group problem on each exam. So I didn't get the whole pattern of the exam, what kind of exam setup was, but they said they implemented they included one group problem on each exam where the student can work together, but they will submit their own solution, own version of submission, but they can discuss that problem in group and then they solve individually. So that is interesting problem. That is interesting thing. I have not seen that before. So initial assessment, they implemented a force concept inventory and the Maryland Physics Expectation Survey. In force concept inventory, the inquiry-based class at Texas Tech University, they got the normalized gain of about 0.3 to 0.4, which is in line with the Hake plot. So on the right, we can see the Hake plot, where the bar, this bar belongs to the traditional courses. So for traditional courses, the normalized gain is around 0.21. And for the interactive engagement courses, the gain is about, the average gain is about 0.48, and it goes from 0.3 to 0.6. So the FCI score at Texas Tech University using inquiry-based course was in the same range, which is defined as the interactive engagement region by the Hake plot. By comparing, let's compare that result with the FCI score for the traditional class at TTU. And the traditional classes, the FCI score for traditional classes was 0.10 to 0.15. So there is a significant gain in understanding using this inquiry-based class. And they also ran the MPEX survey. MPEX survey is a 34-item agree-disagree type of survey that measures the students' attitude, beliefs, and assumption about the physics. There are 6 different dimensions, and it shows significant increase in coherence cluster. It didn't show that much of the significant increase in other cluster, but there was no decrease in any of the cluster surveys. So this supports the basic assumption that inquiry-based course will help students to understand material better. In addition to these concept inventories, they also conduct the internal survey, asking students about how they feel about the course, what was uh, uh, the load like, how the student feel about that. So most of the students responded positively. Some of the students were initially struggling because this is the new tradition, a new kind of teaching. This was completely new for them. So it took some time for them to get used to, but most of the students responded very positively, and they said the most beneficial aspect of the course was hands-on learning environment. So they can learn by doing. So that was the most positive aspect of this course according to the student response. So when between 2004 and 2008, they implemented it to a little bit different population. They offered it to two classes, one for the honors student, which was taught by a physics faculty member who was familiar with the PER, but not a PER practitioner, and another by the science education faculty member, and that class was taught to the curriculum to pre-service math teacher. And the force concept inventory gain was about 0.40, again in the interactive zone. Again, they got the student feedback, and this one feedback was quite interesting. That's why I included this here. I just want to read this statement. This one made us actually think about what we are doing. Some are telling us that this is how it is, and then take formula and put in the numbers. But this one, you actually saw why the formula makes sense. So it is quite encouraging. You are not using it. According to students, they are not just using the formula. They are trying to get the backstory of the formula, or they are trying to get the understanding of how formula works, how formula uh, uh, does work. So that was interesting. And in 2009, they started the Physics 1 and 2 sequence for health science major. They started that class. In addition to the class inquiry-based classes, they also got chance to deal with the laboratory. So they rewrote laboratory manuals to make it PER informed real-time labs. And then they also have some PER informed lectures, PER informed labs. So they have a lot of data to work through. So this time they administer 4 conceptual inventories. First one is force convention, mechanics baseline test, brief electricity and magnetism assessment, and conceptual survey of electricity and magnetism. In this assessment, uh, this graph is the result of the FCI, force concept inventory. So they applied this for different sections. IMQ is the inquiry-based class, which does not have separate lecture and lab. So this RT is real-time lab. Real-time physics is the series of introductory lab modules, which uses computer to get the data and then develop model, so on. So this is the real-time lab. This is with the PR informed lecture. And this is the traditional lab with PR informed lecture and so on. So we can see the bottom one is traditional lab and traditional lecture. So the normalized gain is less than 0.1 in FCI, force concept inventory. If we just change that lab portion to the real-time lab, then the gain suddenly increased. It is greater than 0.15, depending on its appearance. It looks like it is around 0.17, 0.18. And by just introducing the PER inform lecture part, keeping the lab same, the gain jumped over 0.2. And if we, when they offered the real-time lab along with the PER inform lecture, then the gain was maximum. It was more than 0.35. An inquiry-based lecture have gain, it is also 0.3, greater than 0.3, but not as greater as the real-time lab and PER inform lecture. So introduction of RT lab significantly increased the gain on the FCI independent of the lecture style. So we can see here, just introducing the real-time lab increase the gain when we go from the blue bar to the red bar or from the green bar to the purple bar. There is a significant change in gain. So if we just introduce RT, then it can change by significant amount. And this is the BEMA test. For BEMA score, they were not significantly higher, but they showed the tendency of increase in gain, but increase in the understanding, but they were not particularly higher like the FCI test. And one thing they noticed here is the inquiry, especially in the last graph, we can see the gain in the real-time lab associated with the PER inform lecture, that was greater than the inquiry-based course. So the question was, if there is no difference, then why do we need to use the inquiry-based class? Why just we cannot do the PERL associated and attach a real-time lab with that? So that was that question led them to the further another question of how can we assess the thinking skill. So they got that both PERL, PER inform lecture with the real-time lab and the inquiry-based class, both enhance the understanding of concepts. But how does the inquiry-based lab enhances the thinking skill? So that's why they move on to get a tool, a rubric to evaluate the thinking skill. So here is the rubric. They create a rubric on the basis of Bloom's taxonomy. In Bloom's taxonomy, creating didn't have equivalent. They didn't have anything equivalent to the creating, so they left out creating part. And then they combined applying and analyzing. So that's how they created this rubric. And in addition to that, they added one label, zero label, where either the student give the wrong answer, totally incorrect, or the statement only, or partial remember. So they added this zero label, and they combined applying and analyzing in one label, and they removed the creating part. So that's how they created the rubric. And these different labels represent the action descriptors at each level of the Bloom taxonomy. That's how they related the different labels of this new rubric to assess the thinking skill to the Bloom's taxonomy, different level of Bloom's taxonomy. And they identified 7 problems that had been administered across the algebra-based sections over the year, and they did the analysis. So when they did analysis, so this graph is for this problem administered to 2 algebra sections, one inquiry-based and one traditional, both taught by the same instructor. So instructor was same, just the pedagogy was different. And we can see here the non, where the student mostly gave wrong answer or they partially remember, that was quite high in traditional course, but that got decreased a lot when they introduced the inquiry-based class there, and this was taught by the same instructor. So all other factors remain same except the pedagogy. And we can see on the higher level, there is more inquiry-based. The gain is more on inquiry-based classes compared to traditional. Same thing here with another problem. This problem was administered to a little bit more sections, 4 sections. One was 24 student section in 2010, very big class. One was traditional class with 80 students, but it is not completely traditional. They have integrated some interactive engagement in that traditional classes in 2010. And the two are the recent one, 2017 and 2019 inquiry-based students class sections. So the pattern, we again see the same. Traditional class has higher non-label, and as we go towards higher level, we see more and more inquiry-based classes appearing there. So these results shows that students taught in the inquiry-based format showed more evidence of the application of thinking skill than the traditional one. Now the next challenge was to expand these classes from 24 students to 60 student class. So they offered 2 sections of 60 students for each physics 1 and 2, 2018 and 2023. One class of 60 students had 1 faculty member, 1 TA, which is graduate teaching assistant, and 3 for learning assistants. These learning assistants are undergraduate students took this course before and done well, but not necessarily in the same format. So here is the result from those assessments from those classes after expansion. My score were not significantly different from before and after expansion, but there was a wide variation in FCI class. We can see here 2018 section 1, 0.27, and 2021 section 1, 0.41, 2022 section 0.33. So there was a wide variation. And so they were looking for why is that variation. We can see the gain is good, very close to the interactive engagement zone. So gain is there, but why is the variation in gain from one section to other? So they were looking into that. They got into 2 possible explanations for this variation. One, there could be natural variation where from one class to another class, the ability of students. So that could be one reason. And another reason they thought of is the LA's instructional abilities. These LAs, they are the undergraduate students who took this course before and did well. But they are not necessarily from the inquiry-based classes, so they may not be aware of, they may not be very familiar with the pedagogical content. So that's what they thought the cause of the variation is from one section to another section. So next, they wanted to develop to assess the pedagogical content knowledge of Alex, the learning assistant. How well the learning assistants are helping the students, whether they are helping students to guide to the solution or whether they are giving the solution to the students. So that was the main question. So they wanted to develop a tool to measure the LA's pedagogical content, how much aware they are and how much they are applying those pedagogical content knowledge, and especially the Socratic questioning format into the class. So that's what they wanted to look next. So these were the some assumptions going into that. What evidence do we have of the LA's content knowledge, and what over their ability, even if they know whether they can apply that to that in the class, whether they can guide by questioning or whether they would just lecture and the answer. So to develop this tool, they first videotaped the LA's interaction with the student in the classroom, and they minutely analyzed those videos, and then they developed coding rubrics to evaluate the LA's the PCKQ based questioning, the Socratic questioning on the videotapes. And they developed and validated a set of questions that could be used as an indicator for LA's PCK knowledge or the questioning knowledge. So when they analyzed the videotape, they found out two main type of interactions usually take place between LAs and the students. They define the time period of that interaction is the vignette. I didn't include that from this presentation, but when we look into the paper, we'll find that. So the time period when the LA approaches a group and the group will figure out the solution. So that time period is called, given a name vignette. And in that vignette period, they identify two main type of interactions. One is questioning and another is tutoring or lecturing. And within questioning, they further divided those interactions into different type of questioning. One is guiding questions, where LA will guide students towards the right path, and probing questions, when the LA would give them something to probe them, and then sometimes checking questions, simple questions. So these questioning interaction were further divided into these three groups. And depending on that, so they divided this micro rubric where they can identify, they can code the interaction between LAs and the student groups. So the GQ, guiding question, where LA asks question to guide, probing question, where LA asks question to collect information about the student's understanding, and checking question, which are simple questions. And tutoring lecturing, where LA does not questions, but rather than lecture or tutor or give the answer. So, and these different levels of dialog patterns, on the basis of these different level of dialog patterns, they developed a rubric to measure the interaction between them. So they have different level. QA is where the LA mostly in vignette, they will mostly go through the guiding question, guiding, checking, and probing question, but they will not lecture. In QB level, they would mostly use guiding question and then probing, checking question, but in between somewhere, they would also lecture. So that is the QB level. QE level is where either it is QA or QB, but that has some content error, identifiable content error. And DA, DB are basically where they are lecturing. In DA, they are lecturing or tutoring, but they are also using some probing and checking questions. DB level is basically lecturing only, and DE if it has some content error. And these levels are associated with the different components of the Magnusson's definition of PCK. So Magnusson's definition of PCK have different components: orientation, curriculum, student instruction, assessment. So they have mapped the macroscopic rubric they created for the assessment of LA's pedagogical content knowledge. So they mapped this the Magnusson's definition, and they created a correlation between the different coding levels of interaction of LAs with the student group to the component of OCSI. OCSI basically this represents orientation, curriculum, instruction. They didn't use the assessment. The assessment component was not applicable particular case. So if a vignette, if a pedagogical content knowledge of LA is at the QA level, then he will implement the orientation, curriculum knowledge, and student interaction, and overarching instruction strategies. To have all knowledge, he will demonstrate the implementation of all of these category: orientation, curriculum, student instruction. But in QB, the LA will perform all orientation, curriculum, and instruction, but have limited knowledge of specific strategies to guide, to teach. In DA and DB, they have curriculum knowledge, they have students' knowledge in DA, but in DB, they also lack about that as well. So that's how they map the macroscopic rubric, the Magnusson's definitions are. So depending on these rubrics, and first they videotaped the LA's interaction with group, and they created the questionnaire like this one. These questionnaires were developed on the basis of classroom interactions, and in some cases, they simply took statements from there, from the interaction, and they added some contextual information so that when the LAs take this written exam question, they would be clear what the situation was. So they added contextual uh, information, and in some cases they use the direct quotation from the student. And they implemented these questionnaire sets in a sets of 3 to 5 questions, 4 to 5 times throughout the semester. And they used the video observation to validate the pre-response question. So they compared what the interaction was in video, taped in video, and what the answer LAs uh, provided during the written exam. So this is the result of that. So AFTZ, SB, these are the students' LA's name. So in video, for LAAF, in video taping, in interaction with the student group, they use 29% QA and 51% QB. But when they wrote it down in the questionnaire, in response to the questionnaire, in pre-response question, they used QA level of understanding 50% of the time and 25% QB level of understanding, and so on. So we can see the category changes a little bit, but it is in agreement across domain and categories. Most of the LAs performed at QB level. It is a little bit different when they were actually interacting and when they were written response to the questionnaire, but they were in major category, like AF mostly conducted in QA and QB level, and same thing in written as well. And TZ, another learning assistant, it mostly conducted in QB and BA level, and that is same in video and written. So this also validates the tool, the assessment, which they use to assess the pedagogical content knowledge questioning. So yeah, as a result of this assessment, they found that most of the LAs are functioning at a QB level. So this process is still ongoing, and the assessment is still ongoing. So now let's talk about the takeaways from this paper. I didn't find information like when they talked about the conceptual understanding, they compare the inquiry-based class with the PER informed lecture associated with the real-time physics lab. But when they go on to assess the thinking skill, I didn't found the comparison between those two. So that was one thing I'm a little bit not sure why. Maybe they didn't have the data or they didn't want it to do that. But other than that, this is a very good paper. This whole work was supported by 3 NSF grant. So by going through this paper, these are my understanding after going through this paper. Definitely, the inquiry-based course will increase the understanding of students in compared to the traditional courses. And in addition to inquiry-based courses, other PER-informed pedagogies like PER-informed lecture, they also have huge improvement over traditional strategies. Student in inquiry-based course showed the more evidence of application of thinking skills. And it is possible to expand this 24 section class to 66 and 60 students classes. So it is scalable. And there is still a room for improvement on training and preparing LAs for the Socratic questioning method, the PCKQ question. So I think that's all I learned from this paper. There are a lot of things I didn't cover. It talks about the constructivist framework. It talks about the Socratic questioning. So there are so much to go over in this paper, but I think that's all I took from this paper, and I'll continue reading it. I enjoy reading this paper. This is long, but this is very important paper. At that note, I'll like to stop my presentation, and if there are any questions, we can discuss.
Thank you so much, Dr. Paudel, for fantastic presentation. It is like, I mean, it is very nice, like you explained very every steps very nicely. So if let's yeah, thank you so much. Let's give a big round of applause. Excuse me. So if there are any questions, please put in the chat box or unmute and ask to the presenter, so I can read the question. So let's do that kind of informally. So for that part, I would like to stop recording at this point. So thank you so much. So let me stop